This is the apparatus for the meter bridge experiment, where we are required to find the resistance of an unknown standard resistor. So this is the unknown standard resistor, and this is the setup. So basically this is the principle of the experiment, which is just based on the balancing condition of the Wheatstone network. This is the Wheatstone network. The Wheatstone network is said to be balanced when no current flows through the galvanometer here. When no current flows through the galvanometer, then R1 by R2 will be equal to R3 by R4. So these two are the conditions for balancing conditions. So that's what I have stated here in words. So that would be our principle. Then circuit diagram. This is the circuit diagram. So basically A and B, there is a wire connecting A and B. So that's a 100 centimeter wire. So if this is B and this is A, there is a wire here on top of the scale. So it's 100 centimeter. And then there are two gaps here, gap number 1 and gap 2. So gap number 2 and gap number 1, and across which known resistance R is kept and unknown resistance X is connected. So this is the galvanometer, and through the jockey we are supposed to find where is the null point. So this is the connection. So this gap 1, across gap 1 we have connected the known resistor. Across gap 2 we have connected the unknown resistor, which is around 1 ohm here, but in the exam it will be pasted, something will be pasted here. So this is the galvanometer. From here to the galvanometer, the other end of the galvanometer is going to the jockey. So let's see the connection again. This is point A, but since there is a metal connection there, so the potential at this point is equivalent to at this point, and it is equivalent at this point. So we may as well call this as point A. And similarly here, this is point B, but the potential at here will be same as at here and here. So this is our point B. So as we can see, battery positive to point A, battery negative to point B. So that's what I've done here. Battery positive to point A, this is point A, to battery positive, then battery negative goes to point B. Then so across this I have connected the known resistance. So across this gap you can see that I have connected the known resistance, and across this gap I have connected the unknown resistance. And the galvanometer from here, from the midpoint, either is fine. You don't have to connect either to positive or negative, either will be fine. The other end should go to jockey. Now before starting the experiment, you have to make sure that, first of all, before that let's just see the formula. So this is the circuit diagram. Then the formula is R divided by L should be equal to X divided by 100 minus L. Basically your L will act like R3 in this diagram. This is R1, this is R2, and this is R3, and 100 minus L is R4. So R by L should be equal to X divided by 100 minus L. So we can solve for X, which is, this is the formula. Now this is the observation table. At least 3 observations should be made. Now before starting the experiment, you have to make sure that the internal resistance of the resistance box of the circuit basically is negligible. So for that you have to make sure that the every key is very tightly, it's sitting very tightly basically. So make sure that, so if everything is sitting tightly, then the resistance, internal resistance of the resistance box is supposed to be 0. So we'll check that. We'll check where the 0 deflection is occurring. So you can see here, I'm going to just move the jockey, and I'll see, I'll first switch it on. I'll just move the jockey to the left and see where the 0 deflection is coming. So you can see that it's still deflecting now. So you can see that the 0 of the deflection is occurring around here, so at this point. So that means about 5 centimeters. So that means you can neglect the internal resistance, because the resistance of the wire of about 5 centimeter of the wire is proportional to the internal resistance of this resistance box. So you can neglect that, because the resistance of 5 centimeter of the wire is very negligible. So now you have to start the experiment. Now I'll take out 1 ohm, and then I'll see, this is the first observation, then I'll see where is the balancing condition occurring. So I'm just going to move it. Okay, you can see that the deflection in the galvanometer is 0 and it is occurring at around 51 centimeter. So my first reading would be known resistance I have taken out is 1 and the null point is occurring at 51 centimeter. So 100 minus L is 49. For the next observation, I'll take out 2 ohms. The known resistance now will be 2 ohms. Make sure that you put this tightly. Again, I'll check for the balancing condition. Okay. So that is occurring at about 63.6 centimeter. So now my known resistance is 2 and this is 63.6 centimeter. I can calculate this later. For the third observation, I'm going to remove 3 ohms. Known resistance is 3 ohms. Then again I'm going to check for 0 deflection, and that is occurring across 73.5 centimeter. So that would be 3 ohms, 73.5 centimeter. So I have calculated for observations for the other 3 observations also. So you can see that I'm getting the answer to be 0.96 ohms, 1.14 ohm and 1.08 ohm. In the exam, if you wish, you could do the second observation again. So I'm getting 1.14, which may be slightly high compared to these 2. So if you wish, we could do one more observation. So let me do that. So I had taken out 2 ohms. So now I'll take out 4 ohms. So now I have taken out 4 ohms. I'll check for 0 deflection again. Okay, so it's around 76.5. So it's always better to take more than 3 readings. So I have taken out 4 ohms and I'm getting 76.5 if I remember correctly. Just confirming it again. Yes, 76.5. But the reading came way worse. You can see that the 4th reading came way worse than the other 3. So I'm going to disregard this and I'm going to take an average of these 3 values. So when I took the average, this is my calculation. I've just added and divided by 3. This is 1.06 ohms. The actual value is 1 ohm. So the percentage is around 6% error, which is slightly large, but maybe that's because the internal resistance of the resistance box, if we account for that, maybe the error will be lesser than this. So but this is considered okay. So this is how you have to do the experiment based on which is basically to find the resistance of the unknown resistance using meter bridge.